Alright, today's lesson is about classifying polygons. The first thing we have to know is, what is a polygon? Okay, a closed figure. So a lot of times they will try to trick you in the book, and they will draw pictures that look like this. Is that a closed figure? No, because it has a gap. It is not closed. That is not a closed figure. The other thing to note on a polygon is all sides will be straight. You're not allowed to have curves, so no curves. The other thing I commonly say is no gaps. The last way they try to trick you is they will do this. Is that a closed figure? Well, if you look carefully, it has a little piece sticking off. And once again, we have a little gap over here. That's a gap. No gaps allowed. So you can't have those little extra pieces sticking off. Just a closed figure would be a shape in which all the corners and vertices meet up. All the sides meet at vertices. Next thing is the sides. We're going to be counting numbers of sides in order to classify polygons. What did it define sides as? Line segments. So those are those straight line segments. And they are always straight. They are never curved. Vertex, a lot of people say it is the corner. A lot of people like to say it's just the corner of a shape. How many corners are they? That's the simple way to explain it. Convex concave. Those are the next important words to discuss. When we're explaining convex and concave, we like to compare them to each other. I like talking about concave first because I can draw a little picture and it'll make sense. So concave. Who knows what C-O-N means in Spanish? With. So it's a shape with a cave, meaning it caves in. So here's an example. It caves in. A lot of times I like to say a little person can hide in the cave. Concave, a shape that caves in. Not hard. If it's not concave, then it has to be convex. And basically convex has no caves. The next thing to look at is the term in-gon. In-gon. And really it's just saying that term in is a prefix to the part gon. And gon means sides. So in is saying number of sides. So this is how we name shapes. We can actually say four-gon to name a shape, but it has a better name. What's a four-sided shape called? Quadrilateral. So really we don't say that, we say quadrilateral instead. However, when I get up to like 42, does anybody know the name of a 42-sided shape? Okay, it does have a name. I'm not going to make you know it, but we can just say its generic name. We could say it's a 42-gon. I don't know it off the top of my head. It is not common. I can print out a little prefix and suffix thing if you want to go over it sometime. Okay. Next term, equilateral. Equal obviously means the equal symbol. Lateral means sides. Equal sides, a shape in which all the sides are equal. You've probably heard of the term equilateral triangle before. Well, it has that name because all the sides are equal. Similarly, we can break down the term equiangular. What's equa mean? And angular means angles, not hard. Once again, I can use that same equilateral triangle picture and note that. that term is both equilateral and equiangular. And when it is both equilateral and equiangular, we call it regular. So regular means both equilateral and equiangular. In example 1, it says, tell whether the figure is a polygon and whether it is convex or concave. The key trait that I want you to focus on is the word concave. Figure out which ones are concave first, because I think those are the easiest because they cave in. Which ones cave in? C is concave. Meaning, since that's the only concave one, these have a possibility of being convex. We just got to remember our definition of convex. The key definition is it has 3 or more sides and they're closed figures. It is a closed figure. It is a closed figure. I'm emphasizing the term a, meaning single figure. So is B a single closed figure with 3 or more sides? Yes, it is convex. And A, remember I emphasized the word a closed figure, a single closed figure. Is it a single closed figure? No, it's more than one. So this one is exactly, or it is neither. It is neither convex nor concave because it's actually multiple convex figures. So that's kind of a trick question. All right, on the checkpoints it says tell whether the figure is a polygon and whether it is convex or concave. Try that real quick. One thing I accidentally skimmed over is tell whether it is a polygon or not. So really it wants a yes or no answer on each of these. Is this first one a polygon? No, it's multiple polygons. So it's not a polygon, singular. Is this a polygon on part B? Yes. And is this one a polygon on part C? Yes. They're closed figures and they are single figures. Similarly on the checkpoint, is part 1 a polygon? Yes, single figure, closed. Is 2 a polygon? Oh, what's that piece right there? It is curved. That means no, because it is curved. But back to this one, is it concave or convex? Does it have a cave? Does it cave in? No, therefore it is convex. Good job. In example 2, it says classify the polygon by the number of sides. It says then tell whether the polygon is equilateral, equiangular, or regular. I'm going to provide some help for you. Remember, a polygon generally has 3 or more sides. So a 3-sided shape is called a triangle. Let's write these out. Triangle. A 4-sided shape is a quadrilateral. And you can think of a 4-wheeler being a quad. Tri is 3. 5. Pentagon. There's a special government building named Pentagon. It has 5 sides. And that's that pent. Penta means 5. 6. Hexagon. Hexagon. I have a trick for that one. 6 and hex. They both have X's. Hexagon, 6, they both have X's. 7. Sept is the common thing most people say, but it's not sept, it's actually another H. Heptagon. Heptagon, H-E-P-T, hept. Hept. I'm pretty sure septuplets mean somebody has 7 kids at once. Kind of remember it like that. 8, everybody generally knows. Octagon, just like an octopus has 8 arms, legs, tentacles, whatever they're called. 9, nonagon, good job. That was a good one. 10, decagon. They generally don't say 11 much. They'll just say 11 gone. But 12 does have one. Dodecagon. Now let's compare that back to the example. How many sides are on that picture? 8 sides, therefore it is a octagon. So it has 8 sides. It is an octagon. It's also equilateral because it has equal sides. And it's equiangular because it has equal angles. Not bad. On example 3, it says the head of a bolt is shaped like a regular hexagon, hex meaning 6 sides, they both have x's. The expressions shown represent the side lengths of a hexagonal bolt. Find the length of a side. What we really need to focus on is that this shape is regular. And what does regular mean? Equal angles, meaning all these angles are the same size, so we can put these little angle arcs, meaning they're congruent. We also know the sides are the same. Good. Those sides are all the same. Well, we learned earlier that if 2 sides are congruent to each other, we can set up an equation. And what does that equation look like? 4x plus 3 equals 5x minus 1. And then we can do some simple solving. When we solve, we like to deal with our x's first. Which x should I move? The 4x, because it is smaller. It's always easier to move smaller x terms. I'm left with 3 equals 5x's minus 4x's is 1x, or just x. 2 steps, or 1 step remaining, really. Add 1 to each side. And x is 4. Does that answer the question, though? Find the length of a side. Substitute that value into the equation. So I can just pick out one of these to plug it into. I'll pick the first one. So 4 times x, which is 4, and then plus 3. 4 times 4 is 16. 16 plus 3 is 19. And since it gave units, we need to put units on our answer. And circle our final answer. Good. Now I want you to try these checkpoints. They align with the last few examples we've done. So try them on your own. Checkpoint number 3 says classify by the number of sides. So let's do that first. How many sides does it have? 4, and 4 is a quadrilateral. Good. So I'll write that out. Quadrilateral. Then it says tell whether the polygon is equilateral, equiangular, or regular. Is it equilateral, all sides equal? No. Is it equiangular, all angles equal? So what is it? Is it regular? It can't be regular because it's not both of those. So it's none of the above. It's none of those words. None of those worked. No, we'll just say none of the above. We'll just say none of the above. The next one, it says the expression 4x plus 8 and 5x minus 5 represent the measures of 2 of the congruent angles in example 3. Well, if the angles are congruent, then how can we set that up? Set these equal to each other. 4x plus 8 equals 5x minus 5. We deal with x's first. Which x do we move first? The 4x. It's positive right now, so we need to subtract it from each side. We get 8 equals x minus 5. To get rid of minusing 5, we need to add 5 to each side. We get x is 13. Good job. Now, did that answer the question? Find the measure of the angle, so I have to substitute into one of them. I'll just pick this little first one to substitute into. So 4 times 13, then add 8. And we get 52 degrees for that angle. Good job. So, I was told wrong. It is not 52. It is a final answer of 60. Great job.